science class today. Today, I will urge all students to take their learning materials as I'm about to take you through the topic for today, and that is electricity. Now, when we talk of electricity, electricity is a form of energy produced as a result of the presence of charges in a conductor. Okay, so that is electricity. Electricity is the form of energy produced due to the presence of charges in a conductor. Now, someone may ask, what is a charge and what is a conductor? Now, when we talk of a conductor, when we talk of a charge refers to the positive and negative ions in a body. The positive and also the negative ions in a body is what we talk of a charge here. Now, at our level, we know of only two charges. That is a positively charged and also a negatively charged particle. Now, at our level, we know that the positive charge ion, normally we use protons. We have protons as positive charge. We know protons to be positively charged and also electrons. And also electrons to be negatively charged. Okay, now let's take the structure of lithium atom and look at how these are arranged. Now let's take this to be the lithium atom with atomic number 3. Now lithium, let's take this to be the nucleus of the lithium. It has three positively protons. The shaded circles here are my protons. Let's take this to be the cells around the nucleus. So we have these to be our electrons. Now let's take this to be our electron. Let's take the shaded circles here to be our protons. These to be our neutrons. And the big circle here to be our nucleus. Now, when we take this, you see that we have two charges here. We have the electrons to be negatively charged and also the protons to be positively charged. Now, you see that the protons here, they are stuck within the nucleus, but we have the electrons revolving around the nucleus on cells. Now, at our level, we have two main types of electricity. We have charges being at rest in a conductor or charges moving in a conductor. At our level, we are going to look at charges moving in our conductor. So the charges that we are going to talk about is more specifically on the electrons. So when we talk of the electrons, think of electrons what's moving. The electrons here are serving as our charges, okay, in the conductor. So when I talk of the charge, think of what electrons moving to give us what we call the current electricity. Okay, current electricity. So basically we have two types of electricity. So let's take this to be electricity. This to be the current electricity. The current electricity, and this one to be the static. The static electricity. So the current electricity, we have the charges moving, and the static electricity, we have the charges being at rest. within the conductor. Okay, so when we talk of charges, that is what the charge, the positive and negative ions in the body is what we call the charges. Now let's look at what a conductor is. Now when we talk of a conductor too, a conductor is just a material that allows electricity to flow through it. It's what we term as a conductor here. Okay, an example, we have a typical example to be copper wire. Now this copper wire here is a metal, okay, and this copper here is a very good conductor, meaning that it allows a maximum amount of electricity to flow through. So this copper wire that we are having here is mostly used in our various homes, in our wirings or connections. The wires that we see, they are mostly made of this metal, copper wire. Apart from this, we can also talk of other metals, all metals at all metals that you know, they are all what we call conductors. They are good conductors. We can talk of the group 1 and to group 3 metals. Okay, group 1 to group 3 elements, they are tend to be metals. Apart from this, you also have the transition metals there, and copper here is a transition metal. Okay, so if you are asked to give examples of conductors, you can talk of copper wire, then you give any other metals that you know. You can talk of magnesium, which is in group 2, okay, and it's a metal. We can talk of aluminium in group 3, which is also a metal. Okay, so these are examples of conductors that we can talk of. Now let's go to what we call the sources of electricity, because someone may ask, where at all can we get the electricity? Okay, now we have so many ways that we can get electricity, and electricity here that we are talking of, we said that it's a form of energy. He said that electricity is a form of what? Energy. So let's look at something here. Okay, so sources of electricity. We said that electricity is a form of what? Energy. And we said that energy can neither be created nor destroyed, but can be transformed from one form to another, as said by the law of what? Conservation, under introduction of energy in year 1, as we did. So now electricity being a form of energy here means we can neither create energy nor neither can we destroy what? Electricity. So if you want electricity, it's just what? Converting energy from one form to another. And the other form we are talking about here is what? Electricity. So transforming energy from one form to what? Electricity as another form of what? Energy. So first of all, we can talk of what? Converting what we call solar what? Energy. That's the energy that we get from the sun into what? Electrical energy. Okay, and that is by the use of a certain device called solar panel. So we can use solar panel to convert what? Energy from the sun to what? To electricity. So the source of electricity here is from where? The solar panel. Now we can also talk of another device, and that is generator. Now the generator here converts mechanical energy into what? Electrical energy. So therefore we can get electricity from where? Generator. Now let's look at the third one. We can also talk of what we call windmill. Now the windmill here, okay, as the name suggests, wind and what? Mill. Okay, the windmill here is a device, as we have generator and solar panel to do what? Devices. The windmill too is what is a device. But this one, you see, when air blows, the air is moving with what? With a certain what? Energy or current. We have something called air current. So what this windmill does is it converts the energy with which the air is moving with what? Electricity. Okay, so we can also get electricity from the windmill. Now let's look at the commonest source of what? Electricity that we mostly use in our radio sets and other other electrical gadgets like torches. Okay, that one is what we call the cell. Okay, cell. Now when we talk of a cell, okay, a cell is what? Is a device, and this device converts chemical energy. It converts chemical energy into electrical energy. Okay, a cell is what? It's a device that converts chemical energy into electrical energy. Now for this cell, we are going to go more into it. We are going to study it furthermore so that we know how the cell operates by converting the chemical within it to electrical energy. So now let's look at a cell as a subtopic. Okay, so we define a cell as what? A device that converts chemical energy into electrical energy. Now when you take a cell, okay, you see that let's take the normal cell that we have in our various homes. We have a cell called sunwatt, okay. Now when you take this battery or this cell has some black substances within it. Those black substances that we see is what we call the electrolytes. Now another major thing that we can see is a strip, a metal strip within it, and that metal strip is what we call electrode. Now having known what electrolyte is and electrode, okay, as in the sunwatt, if you are asked to define the electrolyte, okay, the electrolyte is defined as what? A compound which when in the aqueous state or in the molten form can bring about the conduction of what we call electricity, okay. So the electrolyte here is what? A compound, okay. Someone may say a compound, okay, which when in the aqueous state or in the molten state or form can bring about the conduction of what? Electricity. So the black substances within the sunwatt cells, okay, is what? Is an electrolyte. Now the electrolyte, we can take another example of what? Of a cell, and that cell is normally what we call a secondary cell. That cell is normally used in cars and we call it car battery. Now the name that we give to that particular car battery is what we call the lead acid accumulator. Now this lead acid accumulator, it uses an electrolyte. That electrolyte is called tetraoxosulfate 6 acid, okay, what we call H2SO4, tetraoxosulfate 6 acid. This H2SO4 is what? It's an electrolyte. So now I'm going to show you how the electrolyte works, okay. We said that electricity is what? Is a form of energy produced due to the presence of what? Charges in a conductor. So now it is these electrolytes which is going to decompose or break into ions to give us what? These charges. So now this H2SO4 here what? Dissociates into ions to give us, it dissociates into ions to give us H plus and plus SO4 2 minus, okay. So let's balance our equation here. We have 2 here. Now our equation is balanced. So the H2SO4 here, you see it has dissociated into what? Ions. We have the H plus and the SO4 2 minus ions. So now because we have charges here, we can get what? Electricity. But how is this what? How are these charges going to what? To flow? And they are going to flow within what? The electrode here. So now when you are asked to define electrode is defined as a metal strip, okay, through which electrons enter and leave the electrolyte, okay. the electrode is a metal strip, or it's a metal for short, through which charges enter and leave the electrolyte. That is what we call an electrode. Exactly. Okay, so that is for today. Our next meeting, we are going to look at the importance of what electricity in our various homes. Thank you.